This is an introduction to Module 5 of making spatial decisions using GIS and remote sensing. And this is going to be a coverage of unsupervised classification. This is a screenshot of the area around Chesapeake Bay that you've been working with and that you'll work with in Module 5. And you can see that there are different colored pixels and that there are the different counties that have been labeled here. You can also see the water bodies of the Chesapeake Bay colored in blue. So unsupervised classification is an automated process of determining land cover, and you represent different pixels in a remotely sent scene. So ISO cluster unsupervised classification is one of the tools that you can access in ArcGIS. You can see here there are other tools: maximum likelihood, class probability, and principal components, but you'll be using ISO cluster classification for this exercise. So it's a process of taking a Landsat scene like the one that you see on the left, which is actually a scene from the South Luangwa National Park, and this is in Zambia. The red outline that you see is the border of that national park, and it was from a Landsat 8 platform, path 170, row 69. And what you're doing is you are letting the computer take the area that you designate and determine what the classes are in that area. So this is an example of a clipped Landsat scene to just focus on the national park boundary. And it was run, the analysis was run with 40 classes selected. So you, as the analyst, can choose how many classes you want to run in the unsupervised classification. Here's an example from your lab of an unsupervised classification of the Chesapeake Bay, and the image has what's called a salt and pepper effect. It hasn't been smoothed or filtered, and so this is just based on algorithms, and the computer puts information into classes using the ArcGIS functionality. So what is a class? It corresponds to a meaningful grouping of locations. It can also be called a category. Some examples are forest, water, or high wheat yield. And in your labs, you'll also be working with urban and wetland, as well as others. So each location is characterized by a set of vector values. There's one valuable or variable for each band. This here is showing you a comparison between band 1 and band 2, and there are 5 classes that have been grouped into class intervals. The mean values for each class are shown by the dots on the line and numbered 1 through 5. They're also called mean centers. So a cluster is a grouping of points that in this multidimensional attribute space that makes sense to the computer to put together. So if we look here, we have our band 1 and band 2 comparison again on the left, and you can see that the light gray polygon is drawn around points that make sense to the computer to put into clusters. After that is done, you get a new mean that is redrawn. So now we no longer have that straight line going at a diagonal between band 1 and band 2. You can see that the mean has been adjusted for each of those 5 classes. So in unsupervised classification, you choose the bands, you choose the number of classes, and then the software puts things together based on the likelihood of the digital number values in those bands being the same material or land cover. On the left, we see distances calculated for all sample points between band 1 and band 2, and then the cluster is drawn around those points, and again we come up with a new mean and a new grouping of classes. So to kind of go back, if we go to the first image on the left, if there was no difference in band 1 and band 2, you would have that straight line of the 5 classes. And so there, in the real world, there actually is differences, and so that's why you see the different dots representing digital number values. And then we get the clusters, which again is represented by the gray lines around those groupings. And then finally, the new mean class points. So we've looked at the Anderson land use land cover classification system before in lecture, and this is an example of land covers that have been established. You can see here that number 11 is open water. You can scroll down through that list and see things like ice and snow. There's rock, sand, and clay, different types of forest, going all the way down to the bottom of emergent herbaceous wetlands. And then the numbering is just what would be considered to be metadata. It's a code that's been established for those different types of land cover or land classes. So the classes you'll work with in your lab are water, developed, forest, crop and pasture, and wetlands. So here's an example of a map layout, and one thing that I do want to point out in this map layout is that it's missing something. So when I say missing something, there are map elements that you should include in your PDFs. So there is a title, there's a small north arrow, there is a legend and a scale bar, there is author information and a data source, but it's missing projection. So please, as a GIS user, do as I say and not as I did. Please include projection information on your maps. The only other thing that I would critique on this map is if you look in Legend, there is a file name that is abbreviated, and in a cleaned up, polished PDF version, I would change where it says Unsup F2BC. That's from the directions in your workbook. I would clean that up in a polished Legend. This was something that I created in working through your workbook lesson, but I just wanted to point that out to you because this is a good teachable moment. You're also going to need to make graphs of percent land cover types. I have put the different graphs here according to the counties in the workbook. This concludes the introduction for Module 5.